Hello and welcome to our last experiment, Experiment 12, Electrochemistry.
You might notice that our objective for this experiment is quite a bit simpler from what's listed in our lab manual. In fact, only interested in answering the first of those four questions of the day, because only this first question of the day is really amenable to a virtual lab, to something you can learn from a video. So we want to determine the relative ease of reduction of these five elements: copper, silver, zinc, magnesium, and nickel. Of these, which one's the easiest to reduce, which one's the hardest to reduce. So we could do so by constructing an electrochemical cell where we'll conduct a redox reaction, but by physically separating the anode where the oxidation half reaction occurs from the cathode where the reduction half reaction occurs. And if we have a spontaneous reaction, the electrons will spontaneously flow from the anode to the cathode. And then we can connect a voltmeter to it, and using that voltmeter, measure the cell potential. The cell potential is where we can actually directly measure. What we need to know in order to answer our question of the day, though, is what is the reduction potential at the cathode? That's where the reduction occurs. So I can directly measure cell potential, but the cell potential itself depends upon both the potential at the cathode and the potential at the anode. We can get around this conundrum by making two distinctions in our experiment. One is I'm going to maintain the same anode for all of my experiments. And then secondly, I'm going to define the potential at that anode as exactly 0.00 volts. So if I make those two restrictions for my experiments, use the same anode and then define the anode potential as 0.00 volts, then the cell potential, what I can actually measure, is equal to the reduction potential at the cathode. Keeping in mind, though, that the numbers we actually determine, the potential at the cathode, those numbers are all relative to by definition, a 0.00 volt potential at the anode. Our approach is relatively straightforward and simple. We use a well plate, and roughly in the middle of the well plate, we'll take a electrode composed of the anode, and we'll immerse that anode in about 1 milliliter of a salt solution of that particular anode. And then on one side, we'll do the same thing with the cathode. We'll immerse the cathode, the solid form of the cathode, into about 1 milliliter of the cathode solution. We'll add a salt bridge and maintain electrical neutrality. And then we'll use our voltmeter to measure and record the cell potential. We'll do that for experiment 1. Experiment 2 will be with a different cathode, but once again, same anode. Experiment 3, cathode 3, and finally experiment 4 will be with cathode 4. For our results, we want to summarize the raw data. And so we'll summarize and record the cell potentials. We can read these from the video, but I've also provided these cell potentials for each of these 4 experiments on our Excel spreadsheet. We also want to write the balance half reaction for what's occurring at the cathode, as well as the balance half reaction for what's occurring at the anode, and the overall balance redox reaction for each of these 4 experiments. We have our cell potentials. Keep in mind what we define the potential at the anode to be. And then because of this, what we said earlier about what the potential of the cathode must be. Then to answer our question of the day, we'll take our 5 elements, we'll write down the respective reduction half reactions, and then we'll rank these reduction half reaction potentials from the highest, most positive, down to the lowest, most negative. And that then gives us a table of relative ease of reduction, where the elements higher in the table are easier to reduce, a more positive reduction potential than those that are lower in the table. This is a 20-point lab report. So record in your lab notebook the pre-lab assignment, the procedures, make sure they're full and detailed, observations, your results, those 2 results tables you saw on the previous slide, discussion questions. Discussion questions is that first, how would you construct an electrochemical cell with the highest voltage with these materials? So using the results that we determined in this experiment, which metal should serve as your anode, which metal should serve as your cathode. So how would you actually construct it? Then also calculate what you predict the cell potential of that electrochemical cell to be. Secondly, predict which metal ion or ions should be able to be reduced by elemental copper. And then also briefly describe an experiment to test this prediction. And then finally, as always, make sure you describe several experimental errors or experimental assumptions and what the effect of those errors and or assumptions may be on the results.